Let's begin to dig down just a little bit into each one of these layers. There's 7 layers. I'm just going to warn you, the layers at the bottom are more important. We're going to spend a little more time down there. We're just going to kind of brush through some of the ones at the top. I've added a layer at the top. You'll see the user up there. The user is not really a layer, I don't think, but the user is certainly playing a role in this thing. The user is interfacing with some application software. And in our example of sending the email here, maybe that application is Microsoft Outlook. We'll use that as the example. And so what the application layer does is it provides a means for the user, the person, to interface with the rest of the OSI stack here. And so it's communicating with the application. The user communicates with the application. The application interfaces with the application layer. And some examples, I mean, it could be email, it could be a browser, it could be Microsoft Word or a printer sharing, anything at all. Any application that a user would come in contact with on their desktop is an application that's going to work its way through this model. Presentation. Presentation layer begins to think about what sort of format is this package going to ultimately be in. And so, we're accustomed to file types, things like MPEG files and JPEG files, movies and pictures of things like that. Here's where this packet begins to get formatted into the type of file that it's going to wind up being. And so it's going to get encoded and compressed and ultimately into a very defined format. And you see some examples of those formats there. That's where this process begins. Layer 5 is the session layer. Now, the word session is something that we should probably be familiar with to some degree. And so a session, if I'm going to make a phone call and I pick up the phone and I hear the dial tone, then my session gets initiated. I dial the number, the person on the other end answers, and we have the conversation. So our session is underway. At the end, we both hang up and the session ends. That's a session. It's a communication session. And so what the session layer does, it's designed to control these dialogues between computer systems, these sessions, if you will. And so it initiates the session, it manages it while it's going on, and it terminates the connection at the end. Examples like, we talked about a phone conversation, but it could be just sending an email. And when I click send on the Outlook program, that's when the session begins. It works its way through until the email gets all the way to where it's going to go, and then finally that session gets ended. That's the session layer. Transport layer. Transport layer is important because this is where we start to think about the reliable transfer of information. The transport layer starts to get interested in making sure that we get all the information from where it starts to where it needs to be. And so one of the important things that the transport layer does is that it numbers the segments. And you can think that's very important. If we're going to get them all there in order and all there completely, then we have to have them in some sort of a sequence. And so you'll see here in our example of letters, if I had a lot of information that I was going to send to this individual Jane and all of it wouldn't fit into one envelope, then I'm going to send multiple envelopes. And if I want her to put them back together in order, so that she gets the message in order, then I need to number the envelopes. That's just how that works. And so that's what's going on at the transport layer, is that we're numbering our packets to make sure that they all get there and can be reassembled in order. Layer 3. Layer 3 is important because this is called the network layer. And it really provides the means of transferring data from source to destination across networks. We have to begin to think about networks here. And if you're going to even send an email, even if you're going to send it to someone right across the hall from you, okay, it may not transition too many networks. But if you're going to send an email to your spouse at home, it's going to transition many networks to get there. And so the network layer is responsible to make sure that these packets are transported correctly from one network to another. This layer performs network routing functions. It's a term we should start to get our hands around, this notion of routing. So it performs routing functions and it reports delivery errors. In other words, missing packets. We talked about those sequential packets. Layer 3, the network layer, transports package. It moves packets using something called the IP address. Now that's something that's should be fairly familiar to most of us. An IP address, you'll see an example of an IP address there at the top in that green box. 192.168.150.101. That's just an example of an IP address. And every device on a network ultimately has to have one of those. An IP address is managed Here at layer 3, you'll need to know that IP addresses are assigned by the network administrator. They're temporary. An IP address is not something that's fixed to a computer system or to a network end device forever. So it can be assigned, it can be reassigned, and it's assigned ultimately by someone in charge of that network. We'll see here in our example with letters. In the example of letters, you can see there that if letter number 1 and 2 and 3 got there, and then 5 showed up, we're missing number 4. And this network layer is responsible to see that, hey, we're missing number 4. And ultimately, if packet number 4 didn't arrive, then it can send a message back to the sender and say, hey, we never got packet number 4. Can you send it again? And sure enough, it'll send packet 4 again, and you get the complete message. It's very important. All that goes on here based on this layer 3. In our example of letters, you might consider the postal code, the zip code, as being like the IP address. And you know, the postal facility, at that postal facility down there, they're not interested in the address that's on the letter. They're only interested in zip codes. And they'll know that a zip code came from that direction, and on the sending side and the receiving side, we know that it has to go off in that direction. And so based on a zip code, it just sends it off to a particular zone, a particular area, and it knows what that zone is. It's not particularly interested in the exact address it's going to go to. It just gets it routed in the right direction. Now, in the network world, network routers perform this function. Network routers perform the function of forwarding packets based on the IP address, and routers operate at layer 3. And that's what we should know so far about layer 3. Of course, there's the example of the postal facility we see. So the postal facility is kind of like the network router. Layer 2, important. The data link layer provides a means to transfer these frames, again, it calls them frames, we're going to call it packets, between local end devices. This is where we're really interested in where the actual destination lives. And at this layer, it manages something called the Media Access Control, or the MAC address. And you'll see an example there in the green box of a MAC address. Now, let me tell you, every network endpoint ever made, everyone on the planet now, and everyone that ever will be made, has to have an absolutely unique MAC address. And you may think, well, how is that even possible? Well, it is. We worked out a system that we can make sure that every single end device on planet Earth has an absolutely unique MAC address. Now, that's important. Well, think about the mail system. What if your mailing address was exactly the same as someone else's? That would be disaster, right? You couldn't have a mailing system that worked like that. So we have to have absolutely unique MAC address, and the MAC addresses are managed at layer 2. Back to our letter, consider that the actual mailing address on the letter is like the MAC address. It's very specific. Very specific. And our postal carrier here, he knows where everybody lives in his neighborhood, where he delivers mail. He knows exactly who lives at 2015. And so that's like the MAC address. The MAC address is very, very specific to a particular end device. Network switches transport these packets based on the MAC address. They are very specific. They know exactly where the end device lives. Network switches operate at layer 2. Layer 1. So this is the physical layer, and the physical layer of the OSI model defines all of the very specific details on how you're going to actually transport these bits of information. Just bits. It doesn't worry about packets. It's just worrying about getting a 1 or a 0, on or off from point A to point B. And so it defines electrical specifications, physical things, connector types, radio frequency specifications, all this having to do with device connectivity. And pin layouts and voltages, cable specifications, all sorts of very specific things, frequencies and bandwidths for radio frequency types of connections. The network adapter in a computer is a physical layer device. We'll talk a lot about Cat5 cable later on, but Cat5 cable, or Category 5 cable, the most common physical, or it's the most common wired connectivity method for computer devices. Cat5 cable is the most common, whereas Wi-Fi is the most common wireless connectivity method. And these are all layer 1 types of topics, And of course, they're only interested in just moving bits of data around. There's our postal carrier again. You know, I thought he lived at layer 2, actually lives at layers 2 and 1. Because what happens here, you'll learn that some of the things that we talk about will actually sort of straddle 2 different layers. And so the postal carrier really is living at layer 1 too. So he has to not only handle packets of data, letters, and know where they're going to get to, but he also has to have the feet to get them there and the bag to hold the mail and on, the sort of the physical characteristics in order to get the letter to where it actually belongs. And so he'll exist maybe at layers 2 and 1. We'll see some other examples of that later.